I'm going to go through a few problems from the Math 3 Unit 3 Worksheet 6, factoring by division, and I'm going to start with number 4. Here we're asked to divide using long division. So I'm going to do that. When you do any kind of division, you want to make sure there are no missing powers in your dividend. And so we have an x cubed, x squared, x, -6, nothing's missing, so then we're ready to work through this. So we want the x cubed minus 3x squared plus 8x minus 6 underneath that division sign. We want the x minus 1 to be out here. And what we're going to do is we're just going to focus on the x and the x cubed alone and ask ourselves how many times, or x times what equals x to the third. And you should get x squared. And so x squared goes right above the x squared column. And then what you're going to do is distribute that x squared to x and to -1. And x squared times x is x cubed. I'll write underneath the x cubed, line that up, same power. And x squared times -1 is -x squared. And we change our signs because we're going to subtract. And we end up with 0 minus 2x squared. Then we're going to bring that plus 8x down. We can bring the -6, we don't need it right now though. And we're going to focus on this x and this -2x squared. And ask our question, x times what is -2x squared? And you should get -2x, so I'm going to put -2x right above the x column, and I'm going to multiply that -2x with the x and with the -1. -2x times x is -2x squared. You should always be matching that first one. And -2x times -1 is positive 2x. We want to subtract these, so we switch our sign, make the -2x squared a positive 2x, make the positive 2x a -2x. And this zeroes out, and 8x minus 2x is 6x, bringing down the -6. And one more time, we're going to look at the x and the 6x and ask ourselves, x times what is 6x? You should get 6. And so then multiply 6 times x and get 6x. 6 times -1 and get -6. And change the signs, and we end up with a remainder of 0. And if your remainder is 0, it's you've divided by a factor. And actually we factored it. So it asks, is x minus 1 a factor? And we're saying yes, and the reason is because our remainder is 0. In fact, it's going to factor to x minus 1 times x squared minus 2x plus 6. Number 8. If we backtrack a little bit, it says to divide using synthetic division. And again, we need to make sure what we're dividing, the dividend, has no missing terms. And if there's missing a term in between, we need to write it in. So this one is missing some terms. We need to rewrite it as x to the fourth plus 0x cubed, because there are no x cubes, minus 7x squared plus 0x, because there's no x's, minus 18 divided by x plus 3. And so then we take the coefficients of our fourth degree polynomial here. So there's a 1 in front of the x to the fourth, there's a 0 in front of x cubed, a negative 7 in front of x squared, a 0 in front of x, and a negative 18. And we're dividing by x plus 3. And we could just ask ourselves, what would the x-intercept be? The x-intercept would be negative 3, and that's what we're going to put over here. And then there's a pattern or an algorithm that we follow. And the pattern is we take our first number 1 and just bring it down. And then we're going to multiply. Negative 3 times 1 is negative 3. And then we're going to add it to the next number up here, 0. So negative 3 times 1 plus 0 is going to give us negative 3. And write that here. And we just keep repeating this process as it moves us along. So now we are going to do negative 3 times negative 3, and then add that to negative 7. So it's going to be 9 minus 7, which is 2. And I put the 2 here. And then keep going. Next is going to be negative 3 times 2. And then add that result to 0. And we get negative 6. And write the negative 6 below the 0. And then one more time. Negative 3 times negative 6. And add that to negative 18. So it's 18 minus 18, which is 0. So that last number is your remainder, and so usually I'd separate it. So the 1, negative 3, 2, and negative 6 is your quotient. And so we've used synthetic division, and if we want, we could bring this out of synthetic division. So these are the coefficients. This is your constant. Negative 6 is a constant. 2 goes with the x term, and negative 3 is the coefficient of x squared, and 1 is the coefficient of x cubed. And so we'd write 1x cubed minus 3x squared plus 2x minus 6. That would be our quotient from the division that was taking place here. So is it a factor? Again, we have a remainder of 0, so we say yes. If the remainder was not 0, we'd say no. Number 10, a polynomial f of x and a factor of f of x are given. Factor f completely. Okay, so we know that f of x is x cubed minus x squared minus 21x plus 45. But we also know that x plus 5 is a factor of that. So if we factor this, we could get f of x is equal to x plus 5 times something. And right now we don't know what that something is. But if you have a factor and you have the original, we can divide the original by your factor and find out what that missing piece is. For example, if I had the number 28 and I told you, well, one of the factors is 2, so 28 is 2 times something, I can divide 28 by 2 and find out, oh, that second factor is 14. We're going to do the same thing here, but we're dividing with polynomials. So the coefficients of f of x are 1, -1, -21, and 45. This goes with your x cubed, this is your x squared coefficient, this is your x coefficient, and this is your constant. Make sure you're not missing anything in between. We aren't. And then x plus 5 is your factor, so the root, or the x-intercept, would be -5. Go through the process. We bring down the 1. -5 times 1 is -5 plus -1. So -5 plus -1 is -6. Here we get 30 plus, so positive 30 minus 21 is 9. -45 plus 45 is 0, and we need that remainder to be 0 if it's a factor. So 9 is our constant, -6 is our coefficient of x, and 1 is the coefficient of x squared. And so no longer is it a question mark. We found what goes there. 1x squared minus 6x plus 9. We continue to try to factor this further. We're looking for two numbers that multiply to 9 and add to -6. -3 and -3. So this factors to x minus 3 times x minus 3. And now it's factored completely. Number 12, we're given 1, 0, and we're asked to factor and sketch the polynomial function. Label the x and y intercepts. A 0 is an x-intercept. And it gives us the factor equal to x plus 3. So we know y is equal to x cubed minus x squared minus 8x plus 12. And so we also know that x plus 3 is a factor times something else, and we need to find that something else. Just like we did in the previous problem, we need to use division. I'm going to use synthetic division. So 1 is the coefficient of x cubed. -1 is the coefficient of x squared. -8 is the coefficient of x. And 12 is the constant. Nothing is missed here. We got powers from 3 to 1 and then without. And we're going to divide that by x plus 3, but we put the negative 3 here. That's the x-intercept. So bring down the 1. Negative 3 times 1 plus negative 1 gives us negative 4. Negative 3 times negative 4 plus negative 8. That's 12 minus 8, which gives us positive 4. And negative 3 times 4 is negative 12, plus 12 gives us 0, and we need that remainder of 0. So 4 is our constant. Negative 4 is the coefficient of x, and 1 is the coefficient of x squared. So we found the second factor, which is x squared minus 4x plus 4. Try to factor that further. We're looking for two numbers that multiply to 4 and add to negative 4, which would be negative 2 and negative 2. So we further factor this to x plus 3 times x minus 2 times another x minus 2. X plus 3 gives us an x-intercept at negative 3. X minus 2 gives us an x-intercept at 2, and we get another one at x equals 2. Double multiplicity, it's going to bounce at that spot. So as we get to graphing, I'm going to put a point on the x-axis at negative 3. It's going to pass through that point. I'm going to put a point at 2, and note that it's going to bounce there because we have an even multiplicity. I'm going to look for the y-intercept, so I'm going to plug in 0 for x, and we get y is 0 plus 3 times 0 minus 2 times 0 minus 2, which is 3 times negative 2 times negative 2, which is 12. Put a point up here at height 12. And then I know our graph needs to go through that y-intercept and reach both of these x-intercepts. On the one on the right, it bounces back. On the one on the left, it passes through. And we have our graph. Just make sure we did everything. Let's check. We factored it. We sketched the polynomial. We labeled the x and y intercepts. And I'll stop there.